So this is Unit 5, Lesson 1, Arraylist. Please do the fast start activity first, and then we'll get into the notes. So today we are going to talk about arraylist, but before we get started, we have to remind ourselves about the difference between primitive data types and class data types. So, what are primitive data types? What are class data types? Your primitive data types are just the information stored where the variable is. The class types are the information is stored somewhere else, and the variable name really just stores the location of that information and points to it. So it's important to remember the difference between these two things, because array lists can only store class types. Array lists are really, really powerful in what they can do. But they only store class types, which means you can't put an int inside of an array list. You can't put a double inside of an array list. You'd have to use a plain array unless you use something called a wrapper class. We'll talk more about wrapper classes later, but we can turn an int, an int, into something called an integer, which is essentially just pushes it into being an object and turns that simple number into something more complex. So what is an array list? Well, it's a collection of objects. It can only store objects, no primitive data. I guarantee you're going to get that question at some point. Whether it's a multiple choice question on an exit ticket or a multiple choice question on a test, you're going to see that as a question somewhere. It's similar to an array, but it only holds the references to the objects. It's not similar to an array in that it has a whole lot more power. Because an array list is holding collections of objects, it gains certain superpowers. Very Spirit Week themed. So, a couple of reasons why we use array lists over arrays is the ability to add and remove elements. An array is fixed. Once you decide how many elements are in that array and you declare it, and you set it up, whether it's by storing that information in it right away or in the declaration statement, you say it has 10 items in it, that's it. You can't change it. You can create a new array and store and transfer stuff over, but that it's going to be of a different name. You can't change the original array. The word we use for that is it's immutable. Immutable. Cannot be changed. Array lists are mutable, which means we can change their size. We could start with an array list with nothing in it. And it is sized down so it only holds nothing. Then we can keep adding stuff to that array list, and the array list will expand bigger and bigger and bigger. In addition, it has many built-in methods that allow us to manipulate the information, including insertion, deleting, sorting. So those algorithms that we had to do before manually, in order to get our data in our array to do something, like we wanted to put something into the array, which, by the way, is impossible because something gets kicked out, right? Well, now we can actually do that, and the information will move apart, and the array list will get bigger. Or if we want to delete something from an array, well, we ended up with an empty space at the end, or a double at the end. But now, because of the array list, we have the ability to delete something, and the array list actually will shrink to the right size. And sorting, of course, well, we learned all those sorting algorithms. Wouldn't it be nice if we could just tell the array list to sort itself, and we can. You just say, go ahead, sort yourself. So it has a built-in functionality. It uses an algorithm to sort itself. You don't have to worry about that because somebody wrote it for you. Black box abstraction, that idea of somebody writing code. You don't have to know exactly how it works. You just have to know how to use it. So here's how you declare an array list. There's a couple different ways. First, you have to make sure you import the Java utility array list. You can import it by doing Java or import java.util.arraylist, or you can import all the utilities by doing java.utility.star. That gets everything, including ArrayList. For now, I would recommend getting in the habit of doing java.utility.arraylist. I guarantee you, several of you, when you first start doing this and doing the practice assignments, will open up some other template file. And then you're like, wait, my ArrayList won't work. It'll be because you did not have the import statement. So read the errors. The error message will be something like, name error not recognized, or import error, or something like that. Then there's two methods of actually declaring them. First, you have to say the type. It's of the type array list. Capitalization does matter. It has to be a capital A and a capital L. It's of the type array list. Then you identify the name of your list. It could be anything. Same naming techniques that we've used in the past apply for all variable names, apply to this. Then we set it equal to, and we're going to construct a new array list object using the command new. The new command is the command that calls the constructor to actually build the object in memory. And we're going to say what we're going to build by using the constructor name. The constructor name will always be the same as the class name. Just like when we did scanner, and we said scanner, scan equals new scanner. Well, the name of the class was scanner. The name of the constructor is scanner, the thing that actually builds the class. Here, it's the same thing. The name of the type or the class is ArrayList. The constructor is called ArrayList. When we start building our own classes, we're going to have the same structure. We'll have a name of a class, and we'll have a constructor. They will both have the same name. Why did they do that? I don't know. I didn't write the language. It seems redundant, but that's how they did it. Why not just assume it's the same name? Again, I don't know. That's just how they wrote the language. You could also declare the array list with a specific number of blank spaces already. Notice I said blank spaces. You're not actually putting anything in them. You're setting up memory references that are null. They're not referring to anything. So this one has no memory references in it. It's empty. This has 10 memory references, and they all point to null. So yeah, they're both empty. However, the second one is less empty than the first. Think about what that means for a second. The first one has no references. The second one has 10 references to nothing. It's a little odd to say that, but that's really the way the structure works. So in memory, the first one is going to be bigger than the second one, even though neither of them actually store any information yet. So that's a thought that you have to have. Are you going to immediately put information in it? And if you are, I guess it's fine to declare it this way. If you know you're going to put 10 things in it, great. Go ahead and put the 10 things in it right away. If you're not going to put the 10 things in it right away, then maybe declaring it like this makes more sense from a memory standpoint, because you're not wasting memory. When you do this, it sets up in memory 10 spaces and puts nothing in them. It builds 10 boxes for you to put some reference into, but there's no information to put in there. You are not limited to the same class type. That's important to understand. In arrays, we limit ourselves to the same kind of information. We don't have to, but we limit ourselves to the same kind. Okay, so in order to deal with that idea of class type inside the arrays and the array list, we developed this idea of fitting it to one object type. Now, why would you do that? Well, suppose somebody handed you a box that's all wrapped up. And inside that box were a whole bunch of different items of different kinds. When you took things out of that box, you would just know, until you took some time to identify it, that you took a thing out of the box. You wouldn't know exactly what it was until your brain identified what it was. However, if I gave you a box and I said, this is a box of pencils, before you take anything out of the box, you know it's pencils. So everything in that box is going to come out as pencils, and you know to treat it as pencils. That's what this command here is doing. It's telling us that everything that's inside the array list is going to be of the type string, which means anything that comes off the array list is going to be treated as a string. If I don't do this, then everything that comes off the array list is treated as a generic object. There is an object type. The most fundamental type is the object type. It's really, really kind of empty. Skeleton. Can't really do much at all. Essentially, the best thing you can do with it is cast it as something else. That's all you can do with it, is essentially identify it as something else. So it is a good idea, if you are going to have an array list of the same kinds of things, the same type, to add in this additional type declaration to your array list. So instead of just being array list breeds, it's going to be an array list of strings called breeds, and then we're going to call the constructor of a new array list of strings. And again, we have the parentheses here. Empty. We could put a number in there to declare a certain number of them, but we chose not to. Then we have this lovely method that we can use called add, that allows us to add things into the array list. We don't have to say breeds 0 equals boxer, breeds 1 equals dozen, breeds 2 equals poodle. We just got to say, yeah, add that to the list. Just put that in. So here is an example in code of what this would look like. We have our public static void main. We've declared our array list. Notice I didn't say what this is an array list of. So right now, as far as this array list is concerned, it doesn't know what's in the box. It has to take it out and look at it before it can do anything with it. Even though they're all strings. It would have made more sense, since I'm using all strings, to say array list of strings and use that less than symbol, greater than symbol, and then put that here again, less than symbol, greater than symbol, if I was going to use strings, because that way I would know that the box contains strings, and everything that came out of the box I could treat as a string. But right now, Java has no idea what's in the box. You take it out, it has to figure that out. That's a problem for a couple minutes. However, we can print the list. Well, that's kind of interesting, because we couldn't really do that before, could we? If we went to print the list, what we ended up with was like some type of reference information. I think this is your startup file. Why don't you go ahead and try to run that and see what you get. So if you trace this, we can see that it creates in memory some array list called list, creates an instance of it. Then we're going to add items to the list. Added items to the list. And then we're going to print it out. And boom. When we print it, we get the actual information. Because ArrayList has this ability to automatically call what's called the toString method. If you print list, it automatically gets associated with a method called toString, and will try to print out the individual toString methods of whatever object's in there. So if it can print it as a thing on the screen, it will. If it can print it on the screen as a thing, it will. Whereas before, when you tried to print an array, and I know some of you tried to do this, all you got was a bunch of junk. It wasn't junk. It was actually the reference location for that object, is what you were getting on the screen. But it wasn't the contents. That's a major advantage, being able to print out the contents of the array just by saying print list. Now, you might want to format it a different way, but if you just want to get the information out, yeah, that works great. No for loops. So far, I haven't used a single for loop. I added information. I printed it to the screen. Wow, this is already so much better than using regular arrays. No for loops so far. So I can also use the scanner. It also has a toString method, so it will pull in an object. So we can get input from the user. Here are the different versions of add, and then a couple new methods for you. So first off, add is clearly overloaded because there are two different signatures for it. One signature adds E to the end of the list. A second signature inserts E at location I. So it's somewhere in the list. It pushes it into the list. Again, those sorting algorithms become so much easier. I don't have to run for loops to move things around. I can just, yeah, put that in the list in the right spot. So I really didn't do much sorting and searching yet with actually writing code. Array lists are so much easier to work with in terms of that. List.set resets a value at a particular index. So essentially replaces whatever's in the box. List.get returns the value at that location. So you can't just do list and put an I like you would do with an array. You actually have to call a method to get the value that's at that location. And finally, list.remove takes the element out of the list and shrinks the list. It essentially allows you to delete a particular element in the list. This header up here is up here for a reason. What methods do I need to know for the AP exam? This is what you have to know for the AP exam. Add, set, get, and remove. If you don't know those for the AP exam, then you're not going to do well. Okay? Memorize those for the AP exam. However, there are other useful methods that you can use on the AP exam. List.size. Really? Really? Size? They couldn't have gone with length? Nope. We use length too much. Let's just throw them out something different. Let's call it size. Really? Array lists, to get to the length of the array, you have to use a command called size. Returns same type of information. List.contains. This is cool. It just gave you a searching algorithm. So does it contain this item? True or false? That's it. Remember that word cloud you were doing? Right? You had to do it as a string, and some of you wanted to do it as an array. And you said, wouldn't it be great if we could just look in the array and see if that thing was in the array? Well, now you can. List.contains, just true or false? Yes, it's in the list. No, it's not. List.clear. A little scary. Delete everything that's there. Now, this doesn't change the size. At least I don't think it does. I believe all it does is sets everything to null. So in memory, all the spaces would still be there. It's different than individually deleting every item. So list.clear, through some experimentation, we found out does delete everything that's actually in the list. It doesn't just do null, null, null. It actually eliminates everything in the list. So it's more like list.delete all. Okay, so